FT232R USB to Serial Universal Asynchronous Receiver Transmitter Bridge by FTDI. Welcome to the training module on FT232R USB to Serial Universal Asynchronous Receiver Transmitter Bridge. Today's outline consists of an overview of FT232R, key features, and USB to RS232, RS485, and RS422 configurations. The FT232R is a USB to Serial Universal Asynchronous Receiver Transmitter Interface device, which simplifies USB to serial design and reduces external component count by fully integrating an external EEPROM, USB termination resistors, and an integrated clock circuit which requires no external crystal into the device. It has been designed to operate efficiently with a USB host controller by using as little as possible of the total USB bandwidth available. The FT232R includes onboard EEPROM as well as a master clock generator, 3.3-volt LDO regulator, reset generator, and USB termination resistors. The fully integrated EEPROM allows configuration of the control bus functionality, signal inversion, and drive strength selection. There are 5 configurable CBUS I/O pins to be configured as sleep, transmit enable, power enable, MCU clock output, LED drive, or GPIO pin. The FT232R also includes the FTDIChip-ID security dongle feature. This FTDIChip-ID feature allows a unique number to be burned into each device during the manufacture, which can be used to protect any customer application software being copied. The FT232R supports both synchronous and asynchronous bit bank mode. Each FT232R USB Universal Asynchronous Receiver Transmitter IC has a unique identification number burned into it during manufacturing process, the FTDIChip-ID. The FTDIChip-ID is readable over USB, but cannot be altered by the end user. This feature provides a way of typing application software to a specific device with a high level of security. To read the device FTDIChip-ID, the proper drivers need to be installed, and a separate DLL to read the FTDIChip-ID is also required. The FTDIChip-ID can be encrypted, and this encrypted number can be stored in the user area of the FT232R internal EEPROM and can be decrypted, then compared with the protected FTDIChip-ID to verify that license is valid. Web-based applications can be used to maintain product licensing this way. Here is the block diagram of the FT232R. The internal EEPROM is used to store USB vendor ID, product ID, device serial number, product description string, and various other USB configuration descriptors. It is also used to configure the C-bus pin functions. The 3.3-volt LDO regulator generates the 3.3-volt reference voltage for driving the USB transceiver cell output buffers. The USB transceiver unit provides the USB 1.1 or USB 2.0 full-speed physical interface to the USB cable. The USB DPLL cell locks onto the incoming NRCI USB data and generates recovered clock and data signals for the serial interface engine block. The serial interface engine block performs the parallel to serial and serial to parallel conversions of the USB data. A 12 MHz reference clock can be generated by the internal oscillator. The reference clock can be further multiplied or divided using clock multiplier or divider block. The USB protocol engine manages the data stream from the device USB control endpoint. Together with the universal asynchronous receiver transmitter first in first out controller, the universal asynchronous receiver transmitter controller handles the transfer of data between the first in first out RX and first in first out TX buffers and the universal asynchronous receiver transmitter transmit and receive registers. Any of the C-bus I/O pins can be configured to drive an LED. The FT232R has 3 configuration options for driving LEDs from the C-bus. These are TX LED, RX LED, and TX and RX LED. In the left figure, one of the C-bus pins is used to indicate transmission of data, and another is used to indicate receiving data. When data is being transmitted or received, the respective pin will drive from tri-state to low in order to provide indication on the LEDs of data transfer. In the right figure, one of the C-bus pins is used to indicate when the data is being transmitted or received by the device. In this configuration, the FT232R will drive only a single LED. Here we illustrate the FT232R used as a USB to microcontroller universal asynchronous receiver transmitter interface. In this configuration, the FT232R uses TXD and RXD for transmission and reception of data, and RTS or CTS signals for hardware handshaking. Also, the CBUSO has been configured as a 12 MHz output to clock the MCU. Optionally, RI could be connected to another I/O pin on the MCU and used to wake up the USB host controller from suspend mode. If the MCU is handling power management functions, then a C-bus pin can be configured as PWREN and would also be connected to an I/O pin of the MCU. Here we have a typical USB bus power design configuration. USB bus power device gets its power from the USB bus. Basic rules for USB bus power devices are as follows. On plug-in to USB, the device should draw no more current than 100 milliamps. In USB suspend mode, the device should draw no more than 2.5 milliamps. A bus-powered high-power USB device should use one of the C-bus pins configured as PWREN and use it to keep the current below 100 milliamps on plug-in and 2.5 milliamps on USB suspend. A device that consumes more than 100 milliamps cannot be plugged into a USB-powered hub. No device can draw more than 500 milliamps from the USB bus. When the FT232R is used as a USB to RS232 converter, a TTL to RS232 level converter IC is used on the serial universal asynchronous receiver transmit interface of the FT232R to convert the TT levels of the FT232R to RS232 levels. This TTL to RS232 level converter has an inbuilt voltage converter to convert the 5 volts to the 9 volt required by RS232. A useful feature of these devices is the SHDN pin, which can be used to power down the device to a low quiescent current during USB suspend mode. Here we illustrate the FT232R used as a USB to RS485 converter. An external TTL to RS485 level converter IC is needed to convert the voltage levels. It has separate enables on both the transmitter and receiver. With RS485, the transmitter is only enabled when a character is being transmitted from the universal asynchronous receiver transmitter. The TX-DEN signal C-bus pin option on the FT232R is provided for exactly this purpose, and so the transmitter enable is wired to the C-bus 2, which has been configured as TX-DEN. Similar C-bus 3 has been configured as PWREN. This signal is used to control the SP481's receiver enable. In this slide, we illustrate the FT232R as a USB to RS422 converter. In this configuration, two TTL to RS422 level converters are used.